The Intuitive Machines IM-1 mission is over, and SpaceX is gearing up for the 4th test launch of Starship. These are just a couple of the stories we're going to talk about today in Space News from Ad Astra. I'm Swapna Krishna. Welcome! Well, we will start with some bad news from the little lander Odysseus on the lunar surface. This week, Intuitive Machines announced that they tried to revive the lander and failed. Intuitive Machines' lander famously broke its landing gear on the way down and toppled over sideways after landing on the moon on February 22nd. But it still persevered for 7 days, sending back engineering and science data. Before it went dark and the sun stopped shining on its solar panels, though, engineers put Odysseus into a configuration such that if it survived the cold, dark lunar night, after the sun charged its solar panels back up, the little lander would turn on its radio and call home. Well, that time has come and gone. Odysseus did not call home, it has not responded to pings from home, and engineers have determined that the lander did not make it. Note that the lander was never designed to survive the harsh temperatures of night at the lunar South Pole, which can be some of the coldest temperatures in our solar system. For more on lunar night, check out my video. It's disappointing, but not unexpected, certainly. Intuitive Machines is scheduled to launch another Nova-C lander to the moon later this year as part of NASA's Artemis program. In science news, the Event Horizon Telescope released a cool new photo of the center of our galaxy this week. This is a photo of the supermassive black hole at the heart of the Milky Way, called Sagittarius A star. Of course, you can't directly observe a black hole because not even light can escape it. But we can see here the event horizon surrounding it. It's a bright emission ring from the superheated accretion disk surrounding our supermassive black hole. This particular image was released in 2022. Now this is the new image. The lines you see are magnetic fields spiraling around the black hole. They aren't really there, as in this isn't a direct observation. Instead, scientists observed Sagittarius A star in polarized light and added in these field lines over an image from the Event Horizon Telescope. Polarized light is specifically important because light waves can be oriented in any direction. When they are, they're unpolarized. Polarized means the light is oriented in a specific direction. That is crucial here because polarized light can show us how Sagittarius A star's magnetic field is controlling the direction the light waves move. This allowed researchers to measure the structure, strength, and direction of this black hole's magnetic field. These lines show us how the magnetic fields are moving around the supermassive black hole at the center of our galaxy, as well as the fact that they have a clearly defined structure. The magnetic field is generated by the motion of matter circling around the black hole in the accretion disk. These magnetic fields and how they're structured are very important to understanding how black holes interact with the glowing gas and dust that surrounds them. Studying these magnetic fields will help scientists determine how exactly black holes launch jets of matter from their event horizons and accretion disks. These studies, which were published in the Astrophysical Journal Letters, also tell us that strong magnetic fields may behave similarly around other black holes. The movement here also suggests that our own neighborhood supermassive black hole may be emitting jets we haven't detected yet. Moving on to spaceflight, it feels like we just got done with the 3rd test flight of Starship, but SpaceX is already getting ready for their mega rocket's 4th test flight. This week, SpaceX not only rolled Starship out to the launch pad in Boca Chica, Texas, but they also conducted a static fire test of the 6 Raptor engines on the Starship first stage. A static fire test occurs when the rocket is held down by clamps on the launch pad, but all the engines are fired. Basically, the engines are fired, but the rocket remains static. It's a routine part of pre-launch testing. It's not clear exactly when the 4th test of Starship will occur. SpaceX President and COO Gwen Shotwell said at the Satellite 2024 conference last week that they will aim for a 4th test flight of Starship in early May. That would be a 6-week turnaround from the last test. Shotwell also said they would likely not deploy Starlink satellites on this fourth test. Instead, the focus would be on two things: re-entry and landing. But of course, that launch date is dependent on an FAA license. After the third test flight of Starship, which occurred on March 14th, the FAA opened a routine mishap investigation into the flight. They have to close it, and SpaceX will have to take any corrective actions the FAA identifies before the FAA will issue a license for IFT-4. However, given that the third test launch of Starship did achieve its intended trajectory for both stages, it's likely that this investigation will be less of an issue than previous ones. I'll keep you updated as we know more. Let's move on to a little interesting eclipse news. Why is NASA launching rockets during the eclipse? One of the cool things about the solar eclipse is that it's not just an amazing thing to witness, though it certainly is that. It's a unique chance to accomplish some science. NASA is going to launch rockets into the shadow of the moon during the solar eclipse on April 8th. Let's talk about why. The sun suddenly disappearing from the sky during an eclipse does actually have a measurable impact on the Earth. You've probably heard about wildlife acting strangely, birds going silent. But what you might not know is that a solar eclipse has an impact on the Earth's atmosphere as well. The ionosphere is basically the boundary between Earth's breathable atmosphere and space, from 55 to 310 miles up or 90 to 500 kilometers up. It's where a lot of low Earth orbit satellites, including the International Space Station, are located. And it's crucial for communication around the Earth because radio waves bounce off the ionosphere and are directed back at Earth. The ionosphere is electrified because the sun heats up the gases in the upper atmosphere until they lose electrons. But this also means that this region of space is constantly changing. As the sun sets, the ionosphere thins out because the ionized particles recombine, regaining their electrons and neutralizing charges. But then it all starts again when daylight hits. It's worth noting that space weather and solar storms also affect and change the ionosphere. The rockets launched during the eclipse are going to specifically study this effect. As you can imagine, the sun going dark during a solar eclipse is going to have a similar effect on the ionosphere as night falling. The hope is we can understand more about how these sudden changes in our ionosphere affect communication and what we can do to minimize disruption during these kinds of events. It will involve 3 separate launches of sounding rockets from the NASA Wallops facility in Virginia. The first will be 45 minutes before the peak of the local eclipse. Virginia isn't in the path of totality during this total solar eclipse. There will be 1 rocket during the peak and 1 rocket 45 minutes after. If you're in the mid-Atlantic, you might be able to see these rocket launches on the day of the eclipse. Let's end on a note about climate change. A lot of times, climate change and Earth-based science can feel very separate from space science. But a paper from the journal Nature this week emphasizes just how connected the two are. Apparently, the melting of our polar ice caps is actually affecting the Earth's rotation. It's not so bad that the days are going to get noticeably longer or the nights shorter, but right now, we use the leap second to keep our clocks in sync with astronomical time, which measures the precise rotation of the Earth. It's important to have precise time for many reasons, including for things like GPS that need to know exactly where and when you are in order to tell you where you need to go. In the 1970s, scientists discovered that the Earth was slowing, mainly due to tidal friction, which you can think of as ocean tides, but across the entire planet. To keep our time in line with astronomical time, they added the leap second. 1 extra second at the end of the year. There were about 27 leap seconds added between 1972 and 2016. Except now, scientists have found the Earth is actually speeding up. Because meltwater from the poles is making its way to the equator, the Earth has shifted mass and has more bulge at the equator now. Additionally, land that no longer has ice on it, Greenland and Antarctica, is rising, and that's making the Earth more spherical. While the paper posits that a leap second may need to be subtracted from the calendar to keep up, we'll just have to see what happens. And that is about all I have for you this week. Thank you so much for watching. I'm Swapna Krishna, and this is Ad Astra.